Okay, so we finished up last time by kind of running the dyno around a little bit, and that's about as far as I could get with it at that point. I think as going forward, I'm just going to have to try it out and keep an eye on it. Just keep an eye on it and see how it does, and if it has issues, then we'll have to deal with it. But since I'm kind of done working on that for the time being, the next thing I want to do is it's something I've been thinking about for a while. What I want to be able to do is I want to be able to correct my horsepower numbers based on differences in atmospheric conditions. I don't have any kind of a air handler in this room at all, so whatever the weather's doing that day is what the engine gets. So from day to day, the temperature changes, the atmospheric pressure changes, and the humidity changes. Now, creating an air handler for that would be possibly doable, but I think it would be kind of outside of my budget for the time being. But what there are ways, there are correction equations to correct the engine's power output based on, like I said, the atmospheric conditions. The way I got started with this is that I did some research and I did some looking around, and I ended up buying an SAE paper, and of course it's copyrighted, so I can't really show you it. But what it is it's the SAE J1349. To my knowledge, what it's meant for is engine manufacturers who want to get an SAE horsepower certification. They need to follow a set of standards when they're doing their test, so that the test is being done fairly and in a repeatable way. So anyway, that's the standard I'm going to use, and kind of to my surprise, when I read through this, it didn't say anything about humidity, which I'm kind of curious about. I guess there are other standards out there that do account for humidity, and I think the ISO 1585 may account for humidity, but I don't have that information for sure. For right now, what I'm going to use is the J1349, which for whatever reason doesn't account for humidity, but it does correct for temperature and atmospheric pressure. I think it'll do a pretty good job of doing the corrections that I want to do. So what I need in order to do these corrections is I need to be able to record the temperature and the pressure, air pressure inside this room, the absolute pressure inside this room. Now what I'd been doing before when I presented that data was I was just going to the National Weather Service website, and they would show what the temperature, pressure, and humidity were. But the problem with that is that there's a couple of problems with using that. And one of them is that where that's being measured may be miles away from where I live and miles away from here. And then the other thing that's going on is that behind that, I haven't done much talking about it, but in behind that plate there on the wall, in behind there is a fairly large exhaust fan to keep the room cool and to keep gases and things from building up inside of here. The idea basically is just to keep a good constant circulation of air, fresh air coming into the room for a number of reasons. If I have this door shut or partially shut and I have that fan running, it's going to change the pressure inside this room. So what I need to do in order to do these corrections is I want to put a pressure sensor inside this room and have a way of measuring the air temperature inside this room. So that's what this video is going to be about, or at least, so this is going to, I don't know how far I'm going to get with it, but at least this, if I don't get it done in one video, this is going to be the first part of that. So hopefully it shouldn't be too bad. I've got the module that I want to use, so let's go in the house. I need to make an enclosure for it, and then we need to start working out the wiring and the code and the programming to make that thing work. So let's go do that next. Okay, so here's the enclosure I came up with for the BMP 390, and it doesn't have to be anything extraordinary. It just needs to basically enclose it and protect it in general. These holes here are just for ventilation so that air can move through it. That feature there is there so that the data cable can go into the enclosure, and that recess there is so that the pins in the board have some clearance on the opposite side of the board. Alright, so that's where I want to get started with this. Let me send this over to the printer, and we can get started on that. While it's printing, I can just come up with a small cover to put on there. So let me do that, and we'll move on from there. I wired this up using the I2C communication, and it's just 4 wires there. It goes through this cable out through here. I got a bulkhead connector there that's going to go down in here so that I can connect this or disconnect it if as needed. And then I hooked it up to this Raspberry Pi here. I had some trouble with the program as usual. Seems like there's always something. It's never that easy. Yeah, it took a little doing, but I got the programs to work, and we'll look at that next and show you some of the troubles I had there and how I fixed it. The board I used, that has the sensors on it, it was called a BMP 390. There's a website out there called Adafruit. Well, they sell some of those boards and they provide some programming support for them. And that's what I used. Their programming for that board. They provided the program to connect that board to the Raspberry Pi. On their website, they show you how you can do that. Their instructions were good, but what I found to be a little bit easier was I just went to ChatGPT and I think I searched just something really simple. It was like how to connect a BMP 390 to a Raspberry Pi, and it gave me a pretty straightforward method to what I needed to load on there in order to get this to work. I didn't do a whole lot of studying on it, but apparently there was something in there called Circuit Python, which I'd never heard of before. And actually you can see it right there. Anyway, that's just part of it, but that's one of the you need to have Circuit Python on there. I guess in one way you should go through read through the instructions on the Adafruit website, and also use some sort of AI to help you along the way so that you load all the things on there you need. That took a little bit of time to figure out because I'm not really that much of a computer person. I mean, I work my way through things most of the time, but it's not really something I'm really all that good at. And I went through and I loaded all the stuff in, and I kept getting this error. Basically, it was telling me there was a syntax error in one of the files. The file that it told me that the problem was in. So if you look at this string here, it's the directory pathway to the file that had the problem in it. Or I'm not going to call it a problem. I'm just going to say it was something that I changed that at least made the program work for me. So, and what I'll show you where it was. Like it was said, it was in this init file here, and it was telling me. So you can see here what I ended. It was in this line right here, and what I did was I copied. So this is something that I do if I don't really know what I'm doing. I'll copy the line and paste it above it or below it, so that if I make a change to it and I forget something about it, I can just refer back to the other one. So this is the original line here that's pounded out. And the difference between these two lines here is this one has that / in it and this one doesn't. And in the error it told me that it was pointing at this, and it said the syntax error. So I got rid of that there, and I did the same thing on this line here. I got rid of that / and then the program started working. I really don't know what it was there for. All I know is that when I removed it, I started getting out of the program what I wanted to get out of it. And the other thing of it is on like both the Adafruit website and searching through things like ChatGPT, I found some starter programs to start reading. And this is just the program I came up with here. And this is what was in the example program. It started bringing in the values from the sensor, and I think it's bringing them in hectopascals out of the sensor, or out of its program. That's what comes out of its program is hectopascals. And the temperature comes out in Celsius. Anyway, I just do a few different things here to give. I assign some variables to those values. That's the program, and here's our values coming in through the sensors. So what's left to do now is I just need to pipe these. I just need to send these values over to the Raspberry Pi that does the data logging, so it can have those values and it can record them as we go. So not a terribly exciting episode this week, but it needed to be done so that I can, a test that I do on one day, I can better compare the results to that to a test that I do on another day. So anyway, that's all I got for you this week, and I'll see you next time.